so when we talk about function operations, we're talking about our normal operations, addition, subtraction, multiplication, and division, but we're just using function notation. Now, it ends up being pretty easy because the nice thing about our function notation is because we can just add, subtract, multiply, or divide each of those functions separately in order to get the overall answer. The only one that causes us to have a little bit of issues or is a little bit different is going to be our quotient, because notice that because g of x is in the denominator, it cannot equal 0. So sometimes we're going to have to figure out what that restriction would be in order to be able to do the division. So for the most part, for our adding and subtracting, it's going to end up being just combining like terms. Okay. So for our first example, they give us f of x equals 2x plus 1, and g of x equals x squared plus 2x minus 1. And they ask us to find f plus g of x. But like we just saw, f plus g of x is the same thing as f of x plus g of x. And since they give us f of x and g of x, we can just plug those in. And like I said, we're just combining like terms. So I have a 2x plus a 2x, which gives us 4x. We have an x squared that's by itself. And then we have 1 plus a negative 1, which gives us 0. So that would be our answer. And then it asks us to evaluate. So what does it mean by evaluate? What do I do with the 3?
Plug it in.
I'm going to plug it in for x. Now, you could do this one of two ways. We could plug in our 3 into our f, plug our 3 into our g, and then add them together, okay? But since we've already gone through the trouble of finding what f plus g is, we might as well just use that one, okay? If they didn't ask us to do that first, then it might just be easier to plug 3 into both of them. But in this case, we already have it, so we might as well use it. So we end up with 9 plus 12, which gives us 21. Question on that. Again, for the most part, you're adding and subtracting. It's just going to be combining like terms. So, on our next one. This time they give us f of x is x squared minus 4, and g of x is 2x plus 1. Find the given function, and then indicate any restrictions on the domain. They say or range. For the most part, I'm just worried about the restriction on the domain. So, again, when we add, what are we going to do this time? What do we say our adding and subtracting is? combining like terms. Yeah, so I have f of x is x squared minus 4, and I'm adding g of x, so 2x plus 1. So what do we get? X squared plus 2x minus 2. Now, it asks us about restrictions on our domain. So what type of functions are f, g, and f plus g? So f and f plus g would be parabolas because they're quadratic, but g by itself is not. It would just be a linear line. But what are all of those? What could they all be classified as? Yeah, we're dealing with functions, but specifically what type of function? They're polynomials. But yes, so because they're polynomials, they will be continuous, which means there's not going to be any restrictions on our domain. So, anytime you just have like a string of x's and numbers, right? Like x cubed plus 2x minus 3, or x to the 50th plus 2x minus 3. It doesn't matter. If it's just x's with like normal powers and things with numbers, those are just polynomials, so there's not going to be any restrictions. Does that make sense? Okay, so for our subtraction, what do we need to be careful about? What's different about that one?
You can apply negative.
We need to apply the negative. So we have x squared minus 4 minus 2x plus 1. So what do we end up with? X squared minus 2x minus 5. Okay? So a lot of people remember to do it to the 2x, but then they forget to apply it to like the 1. Okay? So just be careful because you're subtracting the whole thing, not just that first number. Does that make sense? So that's why I put the parentheses around it to remind myself I'm subtracting everything. Okay? Questions on either one of those? You feel okay about adding and subtracting? Okay. So next up, we have our multiplying and dividing. So on our first one, we're just multiplying. So it gives us f of x equals x squared, g of x equals x minus 3. It wants us to find f times g and then evaluate at 4. Well, just like before, remember that f times g of x is the same thing as f of x times g of x. So we have x squared times x minus 3. So how do we perform the multiplication? In this case, we're just distributing because x squared is a monomial, meaning it has one term. So, do I have any like terms to combine?
No.
No, so then that would be our final answer. So then the second part asks us to plug in, right, or evaluate. So we would have f times g of 4. Okay, and again, you could do this one of two ways. You could plug 4 into f and plug 4 into g and multiply them. Okay, but you get the same thing as if we just plug in to our new function. So 4 cubed gives us 64 minus 3 times 16. What is 3 times 16? 48. And then 64 minus 48 gives us 16. So that will be our answer. So notice that if I plug my 4 into my x for my f of x, we get 16, yes? And then 4 minus 3 is 1, so 16 times 1 is also 16. So you would get the same thing either way. questions on that? Now, do any of these have domain restrictions on them?
What is X squared?
It is.
It's among-
It is. But is it still a polynomial? Is a monomial still a type of polynomial?
Yes,
Yes, it is.
it's not trinomial.
Yeah, but a
Oh.
trinomial is still a type of polynomial. A binomial is still a type of polynomial. Okay, like I said, as long as it just has x's and like normal exponents, so there's no fractions in our exponents or negatives in our exponents, as long as there's none of that stuff, then it's just a polynomial. Okay. Now, when we start adding in like radicals or fractions, that's when it's no longer a polynomial and there's gonna be like other stuff going on. Does that make sense? Y'all with me? Alright. So, speaking of fractions and radicals and other things, that's what our next one is about. So this time it asks us to find f divided by g and g divided by f, and then find the domains, okay? But this time, notice that our f and g both have radicals in them, and since we're dividing, we're also creating a fraction. So we're gonna have lots of restrictions going on for this one. Okay, we are gonna do this one together, and I will tell you that I probably would not ask you one like this on a test. Okay, but this process would be the same with easier functions. So if we can do this one, then we should be able to do it with simpler functions as well. Are we all with me? Okay. So your first step is just to find whatever they ask us to find. So they asked us to find f divided by g of x. So again, remember that we can just do f of x divided by g of x, which is, in this case, the square root of x divided by the square root of 4 minus x squared. And that's all we have to do for the division part. That's it. That's our answer. Yay. We're done. Kind of. And then they also ask us to find g divided by f of x. So what is that one going to be? It's going to be what?
Basically, but
Yeah, so like our original fraction just flipped. So the square root of 4 minus x squared divided by the square root of x. So that takes care of like the first step, which is really short. Okay, now the next step, finding your restrictions in your domain, is what's going to take a little bit longer. Okay, so how many functions are we combining? 2, right? So that's how many domains we're also going to have to combine. So we're going to have to find the domain for each of them separately and then combine them. Did you have a question?
Square root 4 and x squared.
What?
You're not square root 4 and x squared.
No, because you have a subtraction symbol. So remember that we had a property for our radicals that allowed us to separate multiplication and division with our radicals, but we cannot separate subtraction or addition. Because it would be like if I had the square root
You can't square root of it.
4 minus 2, right? Well, if I were just to like do that, right, this would be 2 minus the square root of 2. But if I actually do that, that would equal the square root of 2, right? So notice those two things aren't going to be the same thing. Does that make sense? Like we can't distribute a square root if we have addition or subtraction. Now if it's multiplication, we can. But that's it. Alright, so like I said, we need to find our two domains like separately before we can try and combine them together. Does that kind of make sense? Yes? So, we're gonna look at our first function. It is just f of x equals the square root of x. Okay? Remind me, what are we not allowed to have in our radicals? Negative numbers. So, what is our domain for this function going to have to be?
X is less than.
If I can't have negative numbers, x has to be greater than what?
Greater than
0, yes. So, or the other way to write it would be 0 to infinity. Can it equal 0? Yeah, because I can take the square root of 0. Agreed? So that one's done. So the one that's going to cause us the most issues or be a little bit longer is going to be our g of x. So we have g of x equals the square root of 4 minus x squared, maybe. So now, for this one, again, we said that the inside stuff has to be greater than or equal to 0, yes? So, our 4 minus x squared has to be greater than or equal to 0. Okay? So what would we do to solve that? Okay, so if I add x squared, right, we would have 4 is greater than or equal to x squared. So then what?
minus
Take the square root, so what do we get?
or 1.
Almost. Not just 2.
And then
Plus or minus 2. But does it make sense to have a positive and a negative 2 being greater than or equal to x? No. So our problem is that we have a quadratic inequality, and those are a little bit different than just our normal inequalities. Okay, so some of us might have seen these before, but if you haven't, don't worry. We're going to go over the steps to solve it all together. So your first step to solve a quadratic inequality, we have to find our critical numbers. And basically, those are just going to be the numbers that make the inequality 0. So we set it equal to 0 instead. So we kind of just like forget about the inequality symbol for a little bit. Well, luckily we just talked about if I add my x squared over and take the square root, what are we going to get? Plus or minus 2. Are we all okay with that? Yes? Alright. So then your next step is going to be to find the intervals that work. So remember that an inequality has multiple answers, right? Like if x has to be greater than 2, well 3, 4, 5, lots of numbers would work. Does that make sense? So remember that I'm looking for the intervals that make this work. So we're going to go like super old school with it, and we're just going to draw a nice pretty number line. And then what happens is we're going to plot our 2 points that we got in this case. So -2 and 2. And we're going to use those to pick numbers. So in this case, notice that we've broken our number line into 3 different spots. So we have stuff that is to the left of -2, stuff that is in between -2 and 2, and stuff that is bigger than 2. Agreed? Yes? Do we all agree with that? So we're going to have to pick 3 numbers, 1 in each of those spots, to plug back in. And we're just going to see if it works or not. If it works, that means that that interval is a part of my answer. If it doesn't, then it's not. So what is a number that would be in my first interval? So I can't include my critical number. It has to be to the left of -2. So we could do -3. So if I plug in -3 back into my original inequality, we would have negative 3 squared is 9. 4 minus 9 gives us negative 5. Well, is negative 5 greater than or equal to 0? No. So that part does not work, okay, because we get a false statement here. We okay with that? So then what's going to be a value that's in between negative 2 and 2? 0. If I plug in 0, what do we get? 4 is greater than or equal to 0? Is that a true statement?
Yes.
Okay, so remember that when we have a number line, how do we indicate that a portion is a part of our answer? What do we do? Like if I want to include all of the stuff in between negative 2 to 2, what do we do for that part? I can't just do a closed circle because I want to include all of that. So how do I show all of that as a part of my answer? Draw a line. I already have a line, so what do we do instead? Shade it in. Yeah, so remember you have to, like when we did inequalities back in like algebra 1, you'd like shade which direction the inequality was going, or shade the stuff in between. Okay, so here I'm going to shade the stuff that's in between those two things, because that's the part that made it work. Okay? And then, what's a number that's to the right of 2? Positive 3. Well, if I plug it in, 3 squared gives us 9. 4 minus 9 also gives us negative 5. So we end up with another false statement. Yes? So the only part that ended up making it work was the stuff that was in between. To the hall, you can.
What?
If you just want to pull this out, either to the back or the hall. If you want to pull a desk, either like to the back of the class or out into the hall. Alright, so we said that this interval is what makes it work. So we know that our domain is going to go from negative 2 to 2, but then we have to decide, are negative 2 and 2 included in our domain? How do I tell them?
With the,
So if I look at my original inequality, what do we have on there? There's an equal sign. That means that it can equal 0. And negative 2 and 2 are what make it equal 0. So we would have closed circles at negative 2 and 2. Yeah. Are we all okay with that? Now remember, the whole goal of all of this stuff over here, right? Was to find our domain for these two functions over here. I'm looking for my domain for these two functions. And like I said, we have to combine these two domains. So notice, like, -2 is in the domain of g of x. But is -2 in the domain of f of x? No. And like 5 would be in the domain of f of x. But is 5 in the domain of g of x? So which numbers would be included in both of the domains?
1, 2,
Not quite.
0.
0 to what?
2.
2. We're okay with that.
Yeah.
Because basically I have to pick the numbers that would make both of those work. So 0 to 2 is going to be my interval. However, okay, remember there's one last thing we got to consider. Remember these are fractions, yes? So what is my denominator now allowed to equal?
G of x cannot equal
G of x cannot equal 0. So here I have 4 minus x squared in my bottom. So like for the first problem. Which one of these, 0 or 2, is going to make that 0? The 2. So that means that I can equal 0, so it gets a hard bracket, but we can't equal 2. Okay, likewise, for my second one, I have square root of x in the bottom. So which one of my numbers is going to make that one 0? 0. So 0 gets a parentheses, and 2 is what gets a hard bracket. Now, if neither one of those made my denominator 0, then just both of them would get a hard bracket, and we would be fine. Questions on any of that stuff? Like I said, this would be the most complicated type of domain question I would ask you, okay? But our next example is something more like what I would ask you on a test, okay? So I want you to try this next question on our own. So you're multiplying and dividing, but notice that you just have polynomials for f of x and g of x. So no square roots this time.
I don't know how to do all that.
But then I think we should have to list what would make it. To the ones that index. So you would say, so the domain restriction would be cannot be.
So we're gonna simplify.
Into this addition with, no, trying to
Simplify some of your different factors. Alright, so it looks like most of us have gotten most of it completed. So remember our multiplication, we're just multiplying together f and g. The only difference this time is that I have a trinomial and a binomial. So we have to multiply everything in the first by everything in the second. It doesn't matter what order you do it in. So like I'm going to take x squared, multiply it by 3x, and I get 3x to the third. Then I'm going to take x squared and multiply it by the 4. If you wanted to do the 3x by the other two first, that's fine. You'll end up with the same numbers as me, just in a different order. So then I get negative 4x squared plus 21x squared minus 28x plus 36x minus 48. This time though we do have like terms that we need to combine. So we have a negative 4x squared and a 21x squared, which is going to give us a positive 17x squared. Then we have a negative 28x and a positive 36x. So we're going to get a positive 8x and then the minus 48. And again, like we talked about earlier, notice f of x, g of x, and f times g are all what type of functions? They're all polynomials. So do our polynomials have restrictions? No. So I don't have to have any domain restrictions on them. Now, for my f divided by g, so I have f of x divided by g of x. So I'm just going to take f of x and put it on top. So x squared plus 7x plus 12. And divide it by 3x minus 4. Now please be careful, because the only way that you can reduce fractions is if they are being multiplied. We talked about reducing fractions. Remember, I cannot reduce things with x's here because I have addition on top and subtraction on bottom. So nothing will reduce in this case. Alright? So please do not just try and start like crossing stuff out. Okay? That is simplified form. That is as much as it's going to simplify. If you wanted to factor the top, it would be x plus 3 times x plus 4. But notice that that doesn't reduce with the stuff on bottom. So it doesn't have to be factored in this case. However, again, we said f of x and g of x are polynomials, so they don't have restrictions. Okay? But what do we have here? The fraction. So what is our fraction not allowed to have? 0 in the denominator. So our denominator cannot equal 0. So x cannot equal 4/3. So your domain would be x such that x cannot equal 4/3. So remember, the main two times that we're going to have domain restrictions are when we have fractions and when we have radicals. And like I said, this would be more similar to something that I would ask you on a test, okay? Or like if I gave you a radical, you would only have like one radical instead of having to combine two different radicals, like on the last one. Questions on any of that?